Bill. Thanks for joining us here on Tags.
Well, thanks for
So
inviting me, Chris.
no problem. So we're yes. So you said that you might give your own introduction, which was
Yeah, I think it leads us into the subject matter that we have today, which is the rope model, right? It's a
okay.
totally different model. And so we need to find out, first of all, the context. I mean, why did I even come up with this? What led me to it, right? And what I can say is the following. In the 1970s, I was a follower of Carl Sagan. I don't know if you heard about him.
Yeah.
Carl Sagan? Okay. And he was a mathematical physicist. He was very popular. He tried to reduce scientific concepts for the normal person, the average person, right?
Yeah.
And I was a follower of him primarily because he was an atheist, and I was very much into atheism. I was born in a family that was not only atheists, but they were militant atheists. And so we talked about religion quite a bit at home, et cetera, right? And so when Carl Sagan came around, I was a follower of him primarily because of atheism. A couple times discussing with people who were religious, they said, prove to me that God does not exist. And so I had no immediate answer for that. And so I said, hold it, I'm going to have an answer next time someone asks me. And so I said, well, why should I reinvent the wheel? I might as well just go to the smartest people on the planet, the mathematical physicists, right? They've already, most of them are atheists, right? And so I said, they're going to have an answer already for me. I don't need to look up or think anything. I just have to find out what the argument is. And I started looking at physics again, which I had taken in college, right? And for the first time, I started analyzing what these people were saying, and I didn't like any of it. I forgot all about atheism. I forgot about God, and especially Carl Sagan. And I started becoming an enemy, a critic of all these people. I said, what do these people believe in? And it turns out, these people believe in, black holes and dark matter and space-time and who knows what else. And I had a problem with all that because I started looking at this and then saying, what is all this about? What does this have to do with science? And so as a result of that, what I did was started looking at, what is light? What is gravity? How is it that a magnet attracts another? And because of this, I started looking at all these features of physics. And it took me about 1.5 years. And one day it popped into my mind. It really grew gradually. But finally, I came up with a notion that light is mediated by a rope. And, today, when I look back, I've been doing this now for 30 years. When I look back at all this, what was really in the back of my mind is, without knowing at the time, it was like subconscious, I was criticizing science. I'm saying what we're doing today is not science at all. And what we're doing today is not physics at all. And what's the problem? The problem is that, we were doing a sort of physics, a sort of science, all the way until the late 16th, early 15th, late 16th, early 17th century. And what they were doing throughout this time was what the Greeks bequeathed to us. And what was that? Well, primarily what Aristotle suggested, which is, just make an assumption and try to figure out how this universe works. What they introduced at the end of the 16th and beginning of the 17th century for the first time, the notion came out that we need to do experiments. We need to test all these hypotheses, as they call them. We need to test this. And because of that, they developed also new forms of math, calculus primarily in the 17th century. So what happened? They introduced experiments and math. And that's what we have today. We have not only what the Greeks gave us as far as what science is concerned, but also we have now experiments to certify, to falsify, as they call it, right? Our ideas. And we have math developed to unfathomable levels. So what's the story? The story is that none of that has anything to do with science. I'm saying that we don't do experiments in science. We do not use math in science. That's not science. Why? We have three problems with experiments, especially with experiments. They have to be completely eliminated from science. Experiments have several problems. The first one is that, an experiment cannot tell you, how this universe works. An experiment is just a description of something. You do an experiment here. Let me do an experiment just to show you. I'm going to drop the spoon, right? And it falls. That's an experiment right there, an observation, right? So I let go of the spoon and it falls. So far, I have not understood anything. I did the experiment, right? It's repeatable. I can measure how fast it falls. I can measure from what height, how much it weighs. I can compare it against a fork and a knife. But that doesn't give me an idea. That doesn't tell me exactly how that experiment happens, how Mother Nature does that magic trick. That's one issue. The other one is that the experiment cannot tell me, is again, it's just a description. It cannot tell me anything about invisible, intangible entities which Mother Nature uses. In other words, if I let go of the spoon and it always falls down towards the earth, we have a situation where, we have the earth attracting, somehow we're attracting the spoon. And what does that mean? It means that the earth somehow is in contact with the skin of this spoon. Okay, we have to rationalize and say something is in contact with the skin of the spoon. That's why the earth draws us downward, draws us towards the center of the earth, draws the moon towards the earth. The sun attracts the earth towards the sun, Jupiter, all the planets, etc. So there's physical contact between the earth and the spoon, but it's something we cannot see or touch. Between the earth and the moon, there's something we cannot see or touch, but there's something physical there that's holding the moon prisoner to the earth and the earth to the sun and so on down the line. So the problem with experiments is first of all, an experiment attacks only belief. It doesn't attack, why do we do experiment? To collect evidence. What's the purpose of evidence? To persuade the jury, to convince someone. Even it could be yourself. You might have one idea and the experiment changes your idea, or maybe you certify your idea, your preconceived notions, right? So you do an experiment for belief, for evidence, and evidence has to do with belief. Belief is not part of science. Belief has to do with religion, not with science. In science, we explain to understand. We explain objectively. We understand. That's where science ends. What continues is belief. I like this theory. The other guy likes that theory. Those are beliefs. That has nothing to do with science. Science is just objective explanation and understanding. And that's where the introduction of experiments screwed us all up on the one hand. The other one is math. Math is also descriptive. Math cannot explain anything. Math cannot tell you what invisible entities are lurking in the dark out there, what Mother Nature and Father Universe use to do their daily stuff like gravity, light, magnetism, and electricity. You will not solve it by doing an equation. An equation is only a description of what occurred. And in math, as well as an experiment, can only or usually refer only to those visible, tangible things. That's why we go to the lab to use our eyes and our hands. So we say, I'm going to run an experiment. Why? Because I'm going to watch, I'm going to look, I'm going to touch, and then I'm going to come back and tell you what happened with the visible, tangible things. I cannot tell you anything about the invisible, intangible things. And that's where we have a problem, because this is mediated by something which is invisible, intangible. I cannot touch the mediator of gravity. I cannot see the mediator of gravity. And yet, this thing always falls to the ground because it's connected somehow to the earth. And so this is where we have a problem with what we have out there today. And so, maybe I can continue now with a question. I propose a rope. That's what I'm going to talk about.
Yes.
Before I can get to that, what do you propose serves as a mediator for gravity, for light, for magnetism? Do you have a media? Do you have an idea? Do you have a proposal?
Yes, I do.
Okay. I'd like to hear it so that we see where we differ. Where if you have a different proposal than
yeah, yeah. Oh, other than so well, this is it. So the rope hypothesis is interesting to me because when I was younger, I used to play with string and like the handle of this thing. I was like 14 or something. It was like so I'd wrap the string around it, and I thought, oh, that was a good model for light because if you rotate it, it's like a barber shop pole, and
right.
so it looks like it's moving, even though it's just rotating. And I think that's a point you bring up a lot about torsion fields and such. Yes,
that's what you were talking about.
Exactly. Yeah. So I thought, well, because we have this issue with the speed of light being constant, and so when we travel, we still read the same speed of light. So I thought, well, if you have this rotating thing, no matter what speed you're going at, it will always read the same if you're kind of if that's your reading on the side. But then of course we have special relativity, which is talking about a light bouncing back and forth. So it becomes a bit more complicated. Or does it? So these are the kind of questions I was wondering about. So I do have I think what you're talking about with a rope, it's obviously a pull force, isn't it?
A what?
A pull force, gravity would be pulling.
Yeah. I mean, hopefully gravity is a pull force because Newton's equation says it's a pull force. If anything, it says it's pull. It doesn't tell you what the mediator is, but it tells you it's a pull force because you got mass divided by distance squared, meaning that if you take the two objects farther apart, because of the distance square in the denominator, you have weak gravity, weak force. That's what, force is equal to all that. And if the masses are very close together, the two objects are closer together, well, then the force is greater. The force of gravity is greater. So it better be a pull force. It better be a pull force.
Okay. So but I think you also say that
Chris, let me just say one more thing there. If it's a pull force, it can only be something between my two hands, between the Earth and the sun, between the Earth and the moon. It's got to be between. It can't be pushing from the outside. It's got to be pulling from within.
Haven't you also made the point that there's no such thing as pull or no such thing as push? I think it is if you push a door, but when you pull it, you're also pushing it from the other side. So it's all push, is it?
No, I don't think so. We have very good notions of what push and pull are. Okay. If you're pushing the door, you're not pulling on it. You can't say that from the other side you're pulling it. That's not a pull.
No, it's the other way around.
It's a push from your hands.
Yes.
We have to identify the object. If you have a rope from the other side of the door and that one is pulling, then you have pull. But if you have push with the hands, we call that push. In other words, you either talk about the hands or you talk about the rope that's connected to the door.
Right. So I think there was, maybe it wasn't you then, but there was some idea. So like, if you have the rope, it's tied around the handle on the other side of the door and you're pulling it, there's still it's still kind of a push force from the rope's point of view. Wouldn't it be as much as like if you were like hooked your hand around the door and pulled it, you're still, maybe it's anyway, somebody came up with that. I thought it was you.
Pull. We shouldn't confuse pull with push. If you tie the rope or a string or whatever to the handle and you're pulling on that, your hands or a machine or whatever, and it's pulling on the string, it's pulling the door. We call that pull. It's only you're talking about a push only in this sense that part of the string goes around the handle. So there's a part of the string that's on the side of the handle that's pushing on the handle. That's why you're bringing that up, right?
For sure. Yes.
But now let's get to the rope model. The rope model doesn't have that. The rope model is not from behind pushing on the atom. It's from the front because it's part of the atom and it's pulling. So the rope is a pure pull. There's no push at all with a rope model.
Right. Yes. So
I mean, let me see if I can give you an analogy. I've got a fisherman's net, right? And I pull on the net, right? And something is stuck to the net itself. Maybe there are fish in there. I'm pulling, there's no pushing on anything. I'm pulling on the net. And that's more or less what's happening with the rope. The rope blends into the atom, so there's no push from behind the atom. It's a pull from in front of the atom. Okay, just want to make sure that's clear.
Okay, yeah. I mean, there was a theory about push gravity a while back. Some people were sort of supporting that. Do you remember the case for that, Bill, or is that because I haven't heard anyone talk about that in years?
About what?
About the force, gravity being a push force.
Yeah, there's a book by what was his name? Tom. I can't remember his last name right now. His name is Tom, and together with other people, they wrote a book called Push Gravity. You can find it out there. I
will look that up actually, because I'm kind of I mean, talking to you now, I'm not sure, like push pull. I'm not sure if it really makes a difference. I think you could make certain cases either way. But my thinking is more towards like a push gravity scenario. I do work. So some of my models deal with gravity as a surface tension force so if you think about surface tension, you have a body of water, and then you have the interface with the water and the air, and how pressure in water works. So if you have a molecule in the center of the water, there's force on all sides, but if it's closer to the top, there's only a force on the bottom, and that, how surface tension works, obviously, that creates this kind of compression on the top. So if you have an object in there or a bubble, you're going to get the water curving up the sides of the bubble. And then, so let's say you had a piece of dust and it's swimming around, and then it gets closer to that, it's going to get sucked up. So maybe we could call it a suck force, which I think is pretty accurate, actually.
Let me give you an example. Here's the moon. Here's the Earth. Okay, this one's the Earth. This one's the moon, right? How does the Earth pull on the moon? How does it push it?
Yeah.
Explain push here.
Well, so this is it. At this point, when you've got this, the body of water is now curving, compressing. And if that's around a spherical object, it's going to be a curvature or compression of the fluid, which is space. And so if
you're saying space is a fluid,
well, we can't see it. It's like fish in the water, It's like, how's the water, Bill? What's water? I don't know.
No, let's begin by defining space. What is space? How do you define the word space?
Yeah, I know you're big into definitions, Bill, and that's great. I'm not that kind of person. So
there is no such thing as space, because space is nothing, and the definition of nothing, because it's a concept, it's that which has no shape. An object, a thing, is that which has shape. Nothing, the opposite, and its antonym, is that which has no shape. So you cannot say that space does anything to the moon. Absolutely. It's not a river. It's not an ocean that's pushing on the moon. The moon is simply being attracted by the Earth. You have to explain how it does it through push. I mean, how does it do it? And again, you have to identify what it is that's pushing.
Yeah.
What physical object is pushing on the moon?
Okay, yeah. So I think we have a disagreement there. And just in terms of our basic definitions or descriptions of this subject, my opinion is, if I was to give an analogy, let's say, this is a bit hard, maybe because I'm just coming up with it. Let's say an alien comes from Jupiter, from like from a planet with a very thin atmosphere, and it doesn't. And then you bring it into Earth, and it's like, Jesus, I can't see anything. It's like, and it's it's a different atmosphere they have up there. So some of their chemical, I'm not great on the chemicals. And so when it comes down here, everything just looks brown or something, because oxygen to the way its eyes have evolved, it's just brown. And it's like, so I can't see anything. It's terrible smog or whatever. everyone goes, what are you talking about? There's nothing there. Like, we have evolved to see oxygen as just clear. And most of the time, we don't even think about it being there. And, well, thank God it is, for obvious reasons.
The atoms, we breathe those atoms.
We need them.
Chris, you have to identify the physical objects. Are we going to do physics without physical objects, without mediators? I need to know what mediator you're proposing for push.
Well, that's what I'm getting
particles?
to.
What are you proposing? Particles?
That's what I'm getting to. Yeah. So my point is that all creatures in the universe, or maybe there's just a default setting where there is a medium there in space, but it has been deleted out of our conscious framework. So we've just filtered it out, or else
what medium is that? But what medium is that? Fine, no problem. We can't see it. We can't touch it. What's the medium?
I would say it has to be, because it behaves in the way of surface tension. That's my argument, that it must be some sort of fluid, right?
It's what?
It must be some sort of fluid because of the surface tension argument.
Okay, so a fluid is made out of matter, some kind of matter, atoms, molecules, whatever you want to call it. I don't care. It's made out of X. There's a fluid. A fluid is something. It's not nothing. Space is nothing. What's the fluid?
No, but I'm saying that there is a
and leave it at that. We need to identify what the object is.
Well,
is it
okay, but I've already done that, Bill. I've said
I have. Then I did not understand it. I'm sorry. Clarify that for me.
Okay, so I'm saying it acts like a fluid, whatever it is, but we cannot see or touch it, and that's
I don't want you to touch it. I want you to draw it for me. I want you to illustrate what it is that you're imagining.
Illustration is to look at a diagram of surface tension.
Of what?
And then all you need to see it is to look at a diagram of surface tension.
Oh, surface tension. Okay.
Yeah, and that will describe exactly what's going on.
Yeah, but that surface tension doesn't tell me what object we're talking about.
Well,
okay, we need to in physics, we need to identify the objects. That's what the mathematicians never did in the last 10,000 years, because mathematics has no use for objects. So no one defined the word object in the last 10,000 years. I had to be the first one to say what an object is for the purpose.
What is your definition of an object, Bill?
I need to know what object is. I'm going to pin you on the object, and I'm not going to let go. That's where your problem is. Fluid is an object. I need to know what fluid is, what that object is.
I'm still on the same point.
It's a very generic term. In other words, fluid is like saying furniture. Well, there's all kinds of furniture. Fluid doesn't tell me anything. We need to identify what physical object we have there. Is the fluid made out of particles? I mean, what are we talking about
here? So the reason why I'm asking about what your definition of object is that I have heard of a definition a long time ago of an object, and it was something that is finite in both space and time was the definition of object. I think that was what I heard. And so you could ask,
is that your definition of object?
No, someone else had that as a definition. He was, I think they were a geologist. They were concerned that because we were removing oil out of the earth, that we left these huge cavernous holes filled with flammable gas, and that all it would take would be for some crack to go down there and someone to drop a match, like proverbially, and then the whole thing would just explode. So. Yeah, and I heard about that. I was like, oh, that's terrible. But then he also had a definition there on his website, and that was his definition. Finite and
what's your definition of object, of a thing?
I will happily go along with that definition. I don't have my own definition. Also, like, your definition is very similar, I think. I just can't.
No, hopefully not. You said something about space and time?
Yes.
No, time has nothing to do with physics. We don't use the word time, the word field, the word mass. We don't use those words in physics. Those are words of mathematics. Those are concepts of mathematics. In science, in physics, an object is this. An object is that which has shape. If it doesn't have shape, it ain't an object.
Right. Okay.
So that's different than you bringing the word space and the word time. Space is the opposite, exactly the opposite of a physical object. An object that which has shape, space is that which doesn't.
Okay. Yeah, that's interesting. I think, though, from the perspective of the universe, it evolves as you're aware with your extinction mechanism hypothesis. Uh, Nothing is going to last forever. Everything is destroyed, remade, blah blah. So
We do
to
for
say that an
extinction.
object is finite both in space and time is actually a very good definition, and one that I would expect you to
Why
agree
do
with.
you think it's a good definition to say space and time? What is
Because
space? What is time? They don't have a definition of time.
oh right, well that's another issue. Yeah, I mean,
I mean,
okay,
you can't use undefined words to define other words. You're talking about space, which they
oh
never
yeah,
define. They bring time, which they never define. They say, oh, an object has something to do with space time. No, it
well,
doesn't. Absolutely not.
I suppose I could come back there, Bill, and say, you criticize experiments, you criticize mathematics for being descriptions, but then your definitions are also sort of descriptions in a sense. So I could just say, you're saying, oh, physics, we don't need it. We don't need experiments. We don't need mathematics. We just need, explanations.
Understand explanations. That's
Right.
what it is.
That's fine.
Physics, science is not descriptions. This is what
Right.
these people have: descriptions, mathematical descriptions, and then they have irrational explanations to follow that. They talk
Right.
about black holes, dark matter, dark energy, Big Bang, wormholes, whatever nonsense. Particles at two places at once. What kind of nonsense is all that?
Absolutely, but actually, before I said explanation, you said a very good point. You said understanding, and I
Yeah.
think that's what we have internally. Like you talk about how we are the smartest thing that can exist, possibly, and that if God came down, He could explain anything to us, we'd understand it. I agree with that. So we have this innate ability to understand things intuitively, and just kind of we get the picture generally. So I think if I say to you the universe is like this, and the things are destroyed and created, and there's space, we understand that intuitively, and then in time any object is going to be destroyed eventually, as it is. The shape is going to be destroyed. It'll go into like little particles or whatever, and they'll reform into a different shape, perhaps, or multiple different shapes. But am I getting away with? Oh yeah. So I think the point where I'm going with this, Bill, is that what is the shape of is space infinite, like the universe? I mean,
It's an irrational question. Let me tell you why it's an irrational question.
Yeah.
And it has to do, again, we go back to definitions. What is a thing? What is a thing? Is that which has shape. What is nothing? The opposite, the antonym, that which doesn't have shape.
So are you saying
Space
the universe is not
space? Hold it. Space is that which doesn't have shape. Space is not a thing. It's not an object. It's not a body. Space is not an ocean. Space is nothing, that which doesn't have shape. That means that if it doesn't have shape, you cannot say that it's whether infinite or finite. Neither one, because the words finite and infinite are adjectives. You can apply them to a chair. You can say, is the chair finite? Is the chair infinite? That makes sense. You can't even say it's infinite because there's no such thing as an infinite chair. But as far as space is concerned, it's not even an object, it's a concept. It's like saying, is love infinite? Well, love is not infinite or finite because it's a concept. Is intelligence finite or infinite? Again, irrational. And the same thing for space. Space is nothing. Nothing is neither finite nor infinite. So it's an irrational question. Only
no, but you didn't answer the question that I asked. I asked,
okay, what's the question?
Is the universe infinite? Not space. I didn't say space. I said the universe.
Universe is a concept too. There's no physical object called universe. Universe is equal to or means objects or matter, right? And space. So those two words form this concept we call universe.
Yes.
So when we say universe, are we talking about the matter? Meaning, yes. Is it countless? Matter, incessantly counting matter? Or are we talking about the space portion, meaning is that infinite? And again, the space portion is neither infinite nor finite. And the matter portion, each bit of matter, every atom in the universe is finite. It's an object. And so when you talk about universe, you're talking about either space or matter. You cannot talk about both in the word universe. So this universe is also irrational. It's a concept. It's not a physical object.
Okay, so we're honing in closer then. We have the matter. And so I think one example that you use, which I think is interesting, is a bubble. No, sorry, not a bubble. A balloon in space filled with air. You pop the balloon. The gas has a shape. And so if we think of that gas as stars and dust, and then that's the universe. So does that have a shape?
No, that's not a universe. Hold it. Let's make sure we understand. The atoms that were in there, the molecules that form the gas, what we call gas, that's the part that has shape. Not the space between them or the space outside them. That's got nothing to do with a group of molecules that you just released from the pop balloon.
Well, but it has shape.
The molecules have shape as a whole.
Yes.
Okay, let's understand that.
That's what I'm talking about.
Take a snapshot, hold it. Let's make sure we understand what the subject matter is. If I take a snapshot of that gas, I'm talking about the gas. I'm not talking about the individual molecules. I'm talking about the whole shebang. We're saying that group of molecules that forms a shape. It's got nothing to do with, for example, the space between the molecules.
No, that's fine. I'm just talking about that shape because we're just talking about the matter in the universe. Does that have a shape or is it infinite? And therefore, and if it is infinite, then is that shapeless is my question.
The first thing we have to get rid of the word infinite. There's no such thing as infinite in science because infinite is an irrational term. Infinite is an adjective. An adjective can only be used to qualify objects, okay? Only for objects. All objects are finite. We're done. The word infinite is an irrational word.
Okay, so then
what you're talking about is incessant counting. Okay. That's not infinite.
Okay, well then, in that case, right, if I'm saying space is an object, like it is a material, a fluid, and that infinity does not exist, then this object should be, at least in some respect, from one perspective, finite and an object.
What's on the outside of this fluid? What gives it shape? What gives it contrast?
So the object is a sphere, and it's four-dimensional. And then we have the. Wait a second, Bill. We have
What's on the? I just need to know what physical object or what thing is on the outside of the fluid, giving the fluid shape. For example,
if you think of space,
if I put oil in a can, right, or in a glass jar, I see a shape there because the glass is giving it shape. I need to know what's giving shape to your fluid.
Okay, think of a bubble, which is like made of a thin film of liquid. On either side of that bubble, it's two-sided. There's oxygen or air or some sort of gas. So if space is like a fluid, then it sits within an even more rarefied gas space.
Hold it. I need to know what's on the outside. You're saying there's gas on the outside of the fluid?
Yes.
What's on the outside of the gas? Gas is a physical object. What's on the outside of the gas? What's giving shape to the gas?
Well, but that would be the same question as what shape does the air have when you pop the balloon or something? It's just irrelevant.
The air has shape because every atom can be accounted for. But you're talking about a gas, no problem. Gas is made out of atoms or some kind of matter. So you've got all this matter on the outside of your fluid. Something has to be on the outside of that gas.
Okay, well, so we're talking about a four-dimensional universe at this point.
No such thing as four dimensions.
Three
dimensions. I don't know what's the fourth dimension.
It's okay. So essentially, you have this bubble, right? This sphere, and you project from that bubble into three-dimensional space, and so it's a stereographic projection.
Space is nothing. Space is not three-dimensional. Space is nothing. Objects are this is
well, I mean, into the like, if you think, because I'm saying that the I don't really know how to say this. So there's like some projection screen and the liquid that we're talking about, which is finite. But it's also infinite because of the way it's being projected. That would be my argument.
But again, liquids All liquids are finite. All liquids are finite. There's no such thing as an infinite liquid, because then it's not a liquid, because it's not an object. All objects are finite.
Well, but I'm saying that the ball, like the sphere, is finite.
Yeah, and what's on the outside of that? That's what
I mean, like what's on the outside of? I mean, you could think about it as a concept. That's perfectly okay with me. Like some sort of
no, if it's a concept, we're not talking about an object. We're not talking about a fluid anymore.
Not necessarily. I mean, the whole thing could be an abstraction,
Chris, we needed to define the word object because of that, because people try to get around the word object, and you can't. In physics, you need to have an object, and all objects are finite. There's no such thing as an infinite object. And if you're talking about fluid, you're using a word that's very generic. Because again, it's like furniture or clothes. There's all kinds of clothes. There's all kinds of furniture. There's all kinds of fluids. You need to find out what specific fluid, what it's made of, and what's on the outside of it. Otherwise, it's not fluid.
Well, no, I think fundamentally there's a difference about how we see the universe, the world, and such. I think it's fair to say that you are a materialist, Bill, aren't you? You're like a strict materialist.
I had to define these words, Chris. That's the reason I had to break my head, because I found out that everybody cheats and tries to get away from the word object and the word exists. So those two words belong to physics. You need to know what an object is for the purposes of physics, and you need to know what the word exist means. You know, an object that has location. And so there's no such thing as infinite in all of science. So the word infinite belongs to mathematics, because they created infinite numbers. And that's why they said infinite counting. No, that's incessant counting, not infinite. Infinite is an adjective, can only be used to qualify object. You can use the word incessant for motion. You can say, I count incessantly. That you can say, but you can't say there are infinite numbers. No such monster, not for the purpose of physics or science.
Yeah, fair. So, but I think, like, you know, there's the materialist worldview, and not to go too far into this or anything, but that has come under I don't know if you know, is it Bernardo Kastrup, I think is his name. But anyway, so he realized that or it's come about anyway from philosophers. They're thinking, what's going on? You know how what we see is only a representation of the world through our senses, and that we pick up a cup and we're like, this is a cup, but it's like only our brain interpreting those signals. And so this is a major problem for materialists, because it presupposes that, you know, it causes a problem. There's like a layer of abstraction here. We can't.
Yeah, but the problem is that what we have in our brains has nothing to do with what exists out there. What we feel, what we sense, what we think about, that's got nothing to do with actually exists. Someone might be on drugs for all I know, or drank too much wine. It doesn't mean that he understands what the universe is. The universe, Father Universe, is all the atoms in the universe. That's what Father Universe is. And hopefully there's a fixed number of them. There's not an infinite, incessant counting, right? A number of objects, of atoms or whatever. There's a fixed number of atoms in the universe, and they're floating in space, and space is nothing. So there's no border to space, okay? No border, because space is a concept, and you have all the atoms floating within this nothingness. That's our universe. That's Father Universe in a nutshell. And so, you know, what I think there is irrelevant to what actually exists out there. So the universe is materialist. There's only atoms. Anyone who thinks beyond that is talking about nonsense about, you know, what humans came up with. It's got nothing to do with what actually exists. You know, I can think of whatever is out there. I can philosophize and say, according to my ontology, this is what there is out there. You know, that doesn't make it so. What's out there is out there. And what we think of what's out there, that's separate. Those are explanations, assumptions, or whatever.
Yeah, I think this is deeper than just about like what we think. But I actually don't want to repeat that, because I wasn't really expecting to talk about that, and I'm not sure if I have a handle on expressing how the current thought on this is playing out among philosophers. But you know, there's this concept's been around for a very long time anyway. If we go back to the Buddha, but even way before that, because the Buddhists all got it from the shamans who interestingly enough, took an awful lot of drugs in their practices. So certain hallucinogens, which will stop our perception of time and alter our perception of space. And what they found was that the shaman people would go into this trance where time would just cease to be, and they would be in an eternity. So there was no sense of one moment being differentiated from the next. And then from that, they thought, well, this is the real world, and everything in our universe, which is subject to decay, as we said, is all an illusion. And so the real world. So then they want to. Sorry, let me get this straight. So if we think that there is a timeless like substrate or over universe, and then we're in this sort of what would you call it, like a simulation, like an illusion, then and all of this exists somewhere in a mind. But we're actually getting down to the point. Basically, what they say is that mind before matter, rather than matter before mind. You know that concept where you would say material existed first, and then thinking, perceiving creatures evolved out of it. Whereas in the shamanic version,
the reason you can think is because you have atoms in your head. That's why. It's from atoms that thought comes out, thinking, perception, feeling, etc. Well, first you got to have matter. Without matter, there's no physics.
But this is how we get back to the actually what the philosophers then are saying, and same thing that other people are saying, that when we go, well, I'm here, I'm like a conscious being experiencing the universe and myself. So then it's like, well, how am I doing that? And then if you were to like look inside someone's head, you won't find consciousness in there. And then you can look into the particles and so on and so forth. And every time you find a new thing, like it's still just you perceiving something. So it's like turtles all the way down. You can never get to the point and say, oh, this is consciousness, because it's still you perceiving the thing that you're calling conscious through your consciousness. So consciousness is the brand
consciousness has nothing at all to do with what exists. Existence is separate from consciousness or what people think. Consciousness is only for humans to think, to play around with their minds. But what exists out there is separate from that. It's objective what's out there.
Can you? Well, yeah, no, actually, I'm not saying that there's no objective reality, but we can say that there might be an objective reality that is like collectively dreamt in a mind. So consciousness is still fundamental, even though there's this objectiveness within it. That's perfectly acceptable.
In physics, we have no use for consciousness or for feelings or for opinions.
Well, we kind of do.
Objectively based on the atoms that are out there, period. But people get too sophisticated and they say, oh, but consciousness, bring these words, these 4-letter words into physics. No, the consciousness has nothing to do with what exists.
No, but ultimately we want to understand what consciousness is as well. And we would try to do that through physics, but then we're also trying to understand physics through consciousness. So consciousness, I think, is an integral part. If there's no consciousness there, nothing's going to happen. Everything.
Yeah, but something, Chris, we're getting into subjects today, where we talk about consciousness and whether we're a simulation and stuff of that nature. And nobody can tell you why this ball falls to the floor. We don't know something as simple as baby stuff as this. This is baby stuff. This is, a spoon falling downwards. I mean, how complicated is that? We're sending rockets to the moon. We talk about consciousness, and nobody can explain why the spoon falls to the floor. And we have a problem there, because if we don't know this, there's a lot of stuff that we really don't understand about how the universe works. And I'm telling you that the reason this falls to the floor is every atom of that spoon is bound to every atom of the earth. And now we can understand gravity. We can at least say, okay, I understand it. Whether this is what actually happens is a separate story. That's belief. The question is, I give you an explanation of what causes the spoon to fall. And I'm saying every atom here is connected to every atom of the earth. Now you can understand gravity and the acceleration of gravity. You can see why, it's falling ever faster. And the question also explains, just happens to explain light as well. So you have light and gravity in a single mechanism.
Well, this is it. Going back to that idea I had with the rope around the handle of this brush.
Yeah.
So I only had one rope, I just had like one string. But in your model, you've got these two twisting ropes, which is interesting because one is electromagnetic, one is electricity, the other is magnetism.
What I'm using, remember when I talk about the electric and magnetic thread, I'm just using convention. These are the words that we inherited, and I'm just using those same words because they talk about electric field and magnetic field. And I'm saying, no, it's not a field, it's an electric thread and a magnetic thread. And the words electric and magnetic, those adjectives are just, because of convention. But what I'm saying, what you're staring at here is a rope. You explain light by saying, look, the rope torques. Okay. That's the mechanism of light. We're saying that a torsion along a rope between any two atoms, my hands serve as an atom here, right? That's what's causing light. And why is there gravity? Because again, gravity is a pull force, mass times mass divided by distance squared. And what I'm saying is that if every atom of my hand and every atom of this other hand, they're all connected by these ropes, very invisible, intangible ropes, then the reason they come together through gravity, you have to have a lot of mass, right? But the reason they come together is because they're bound. There's a physical connection between every atom of the earth and every atom of you. That's why when you jump, you fall back because every atom of your body is connected to every atom of the earth. So you have light and gravity in a single mechanism. That's my point. And you can understand what I'm saying because a baby can understand it. But when these people talk about fields and energy and mass, and nobody understands anything.
Yeah, there is but I do have a couple of questions on that.
Yeah.
Just let me get to my notes because so with the ropes. Okay, so well, you have two things. You have a model of light that's a rope, but then you have these ropes. Are they the same thing, or are they not? Are they not different in some sense?
Well, the rope is the mediator, the physical mediator of light, because light, according to the rope model, is a torsion of the rope. Why is it torquing? Because the atom is expanding and contracting, torquing the rope and sending the signal along the rope. So we have not only the torsion is the fastest thing imaginable. It's not just the fastest thing in the universe, it's the fastest thing imaginable. You cannot imagine anything faster than torsion. Why? Nothing can travel faster than torsion. That's why light is the speed limit of the universe, because if you look at a torsion, so the rope in this case, right, it's already connected at the other end. It doesn't have to travel. It just torques in place, and the signal is what takes 300,000 kilometers per second, or travels at that speed, 300,000 kilometers per second along the rope. The disturbance travels, through the rope. And that's why it's so fast, because, you torque a rope, it's quick. It's already at the other end. You can prove this to yourself at home if you want to. Take a rope from your grandmother, right? Where she hangs her clothes, and put two clothespins at one end and the other end. And I've done this with filming it, right? And you pull that rope very tight. You move one of the clothespins, the other one moves instantaneously. Why? Because it's torsion. So, and then you have entanglement. What is entanglement? From one end, you see the rope, and it's going let me see if I can do this. For your end, it's going counterclockwise, right? No, your end has to be clockwise.
Yes.
And from my end, it's counterclockwise. Let's turn it out the other way. Now, how is it going?
Counterclockwise, I believe.
And for me, it's going clockwise. So now we have. So we can answer all these questions that have stumped all these mathematicians for who knows how long, at least for 100 years.
Yeah, no, I mean, it's interesting. However, torsion is instantaneous in your model, whereas the speed of light is
No. Torsion is not instantaneous.
Why not?
It's 300,000 kilometers per second. It has a speed. In other words, the signal propagating along the rope is not instantaneous. What is instantaneous is gravity. Gravity is instantaneous, and it's very easy to see why. You take weight, What is weight? Weight is the force in Newton's equation is equal mass divided by distance squared, right? So we have force, but that force is weight. In other words, what you're looking at is a calculation of weight. Weight is location specific. Location is a static concept. You do not need to move. In other words, if you're an astronaut and you're falling down to Earth, and I take a snapshot of every location that you had coming closer and closer to Earth, for each location you have a different weight. Okay, you have a different weight at each location because the distance has changed between you and the Earth. So right. You have different masses at different locations, meaning you have different weights at different locations. Weight is location specific. Yeah. You should be able to illustrate weight in a photograph, in a static image. You should not. The weight is not something that requires motion, and so it had better be instantaneous, because as soon as you move to the next location, your weight changed instantaneously.
Interesting.
So this notion that the mathematicians came up with, that it takes 8 minutes for the gravity to reach the Earth, that if the sun were to disappear, we would not find out about it 8 minutes later because nothing can travel faster than light. It's absolute poppycock nonsense. Yeah. It's irrationality. If the sun were to disappear, the ropes are, it's like you hanging from the mountain from a rope. Someone cuts the rope. It doesn't take 8 minutes for that signal to reach you. You fall instantaneously, believe me.
Oh, I agree completely. But so the mechanism this is my point. I would have assumed that, well, no, actually, I'm just going to say it now, that the torsion, which I believe is instantaneous, would then be responsible for this.
No.
What then?
No. Torsion is not. In fact, the little c is equal to frequency times wavelength. Little c being the velocity of light, 300,000 kilometers per second. It's a constant. Why is it a constant? Because you have frequency and wavelength. And here you have frequency and wavelength in there. The wavelength is the link length. Each one of these, right? That's a link. The link becomes longer or shorter, right? If I torque it more, I get more links, and each link is shorter. And if I untorque it, each link is longer, and we have fewer links. There you have
the diameter of the rope expand, though, and achieve the same purpose.
I'm sorry?
Couldn't the diameter of the rope expand to achieve the same purpose?
Well, you diameter in this direction, or in what direction?
Yeah. Sorry, because that direction. The first
well, in this direction you have amplitude. This is amplitude.
Yes, sorry, amplitude. Yes, thank you. Yeah.
You do have amplitude. You have amplitude in you have all the features in the rope that we've already super analyzed with the wave. So wave is not a physical object. That's the only problem. It's just a bunch of vectors, numbers, and a field is also a bunch of numbers because it's a value at each point in space. That's the definition of the word field.
Right. Yes. So how is the rope transmitting a signal instantaneously in terms of weight then?
Well, it doesn't do it instantaneously. There's still, when the rope is torqued, it still takes time, right, for the signal to propagate along the rope from one atom to the other. And that speed has been measured to 300,000 kilometers per second.
Yeah, that's interesting. So that's different to how, as I said when I was 14, how I conceptualized this back in like 1997. So still after you came up with your theory, I believe. So the point is, though, when it's twisting, like let's say I'm saying that it is an instantaneous torquing, but the speed that it rotates at creates the illusion of the thing moving across, and that could be done at a specific speed, which could appear to be c. But I don't want to get too much into that. My interest here is it's something to do with how light propagates. So it's moving at the speed of c. So the wave front is you have the rope. Now, presumably that you have these two ropes and they're twisting together as they move forward. Is that correct?
The rope is what?
well, maybe I should ask this in a different way. So if the light is hitting the Earth in then on the far
From the
side of the Earth,
sun, from the sun, you mean, or what?
yes, exactly. Sorry, yeah. So it hits the surface, and then the opposite side is dark. So if it's just light that's connecting everything, but it's dark on the opposite side, then how is the light connected to those?
Well, remember how it works under the rope model. The rope model, you have the sun. The sun, it has all these atoms which are being crunched together. They're vibrating at great speeds. They're torquing the rope at great speeds as well. That means that you have, very, 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 very high frequency, in the gamma range. By the time it gets to the Earth, the speed becomes lower, and this is understandable because if you take any rope, you tie it to the wall, the farther away you get from ground zero, from where the rope is tied, the longer the links get. So by the time that gamma ray gets to the Earth, it becomes, an X-ray or whatever. So the issue is the light propagating along the rope gets the links get longer and longer. By the time it gets to the Earth, right, it gets to your eyes, right? For example, let's say you're staring at the sun, right? So it gets to your eyes, it flickers, right? Makes the atoms in your eye pump as well. But what happens? It doesn't go through the Earth. In other words, it does, but it doesn't. The way it works is it's relayed from one atom to the other. So the light that comes from the sun touches an atom, for example, on the Earth. That atom sends the same signal to the next atom, which sends it to the next atom, and so on down the line, all across the Earth to the other side of the Earth. So obviously, by the time it gets to the other side of the Earth, you're not going to have the same frequency with which it received it. The first atom that got it maybe received X-rays for all we care, right? Or maybe even some visible light. But by the time it goes through every atom on the Earth, because it gets relayed from atom to atom, by the time it gets to the other side, you don't see light.
So this was you did a whole series on this about opacity or something, and
there's right, opacity,
and then so as the light goes through an object, it converts into like heat, I think was your point, essentially.
Well, for example, let's say you look at a mirror, or you go to the pool, and you see yourself, a reflection of yourself at the bottom of the pool, right? It's a clear water, 10 feet of water, right? You look down and you see your face right at the bottom. Yeah. And you say, well, how is it that I see my face? I mean, what happened to light? Well, the light obviously reached all the way to the bottom of the pool and came back, right? We think it's particles going down and coming back up, but it's actually instantaneous. Why? Because every atom of your body, every atom of your face is connected to every atom of the water, which is reflecting, in other words, sending that same signal back to your eyes. So you're seeing yourself again. Why? Because you have every atom of your body is connected by a rope to an atom of the water, which is titillating, it's vibrating and sending that same signal back to your eye. So we can understand it. I mean, in the way they do it with particles, which is a big problem, if the particle has to go all the way to the bottom of the pool, to the base of the pool, and bounce, I guess, and come back up, why doesn't it get disturbed by other molecules that are in its path, both going and coming back? Don't they get absorbed? Uh-huh. Why would that light, that photon, come back to my eye?
Yeah.
So we have a problem with that.
Yeah.
And the rope explains it much better. Also, they do the lunar ranging experiment where they put a lunar ranger, an array on the surface of the moon. They send they shine a laser from the Earth, a very powerful laser, to the array, and they pick up the reflection. And with that, they can tell how far the moon is, etc. That's what they use it for. But the question is, how did that ray go? I mean, if we're talking about particles, discrete particles, or even waves, how did they go one way, hit, and then come back along the same path when the moon and the Earth have both moved?
Yeah.
I mean, don't the photons get lost in space? But with a rope, the moon can go anywhere it wants. What you have is a laser. It's got a very high frequency monochromatic light being emitted, along a rope to an atom on an array, and that signal comes back along the same rope. So now the moon can go anywhere it wants. The ropes never get lost. You're always tied to the ropes. So it's
Yeah.
it's a different mechanism altogether that explains why we don't have to deal with all these loose particles that can get lost. The rope never, if two atoms are connected, this one can go anywhere it wants. The light is always going to travel along the rope.
Yeah.
It doesn't matter where it goes.
See, that's an interesting point you just made there, Bill. You said the light will travel along the rope. So I was getting, I was
It doesn't get lost.
in a different way that the light and the rope are the same thing, but it sounds like you're saying it's a medium, it's a framework. That's what you said, like a medium for the light.
You have to have a medium for gravity, and you have to have a medium for light. Otherwise, we're doing magic. We're doing black magic. We're saying action at a distance. That's the word for black magic in science, the scientific version of black magic, action at a distance. What is that? Teleportation.
That's very interesting, Bill. Thank you very much, because that is the first time I've actually understood your theory properly.
Well, so I made a lot of videos. You just got to look through them, I guess.
No, I've watched many of your videos. I just misunderstood what you were talking about. I didn't realize that the light or the rope was a medium for light and gravity, and that it wasn't like light itself. I thought, because in my model the rope was the light, but in your model it's the medium.
It's a grand unified theory, or theory of everything, where you have in one mechanism, the rope. You have both gravity and light, both synthesized here because it's a physical mechanism. Hopefully, when this ball drops, it's connected to every atom on Earth. Hopefully, there's something here that we cannot see or touch. There's a physical object. Otherwise, we're all crazy. We're saying that this is done by magic. No, Mother Nature doesn't work with magic.
Okay, brilliant. Thanks, Bill. I have every. We did say Rajan, you've been listening the whole time. Do you want to make a comment or a question?
Yeah, thank you very much. It was quite interesting, and it is quite revealing and very, something new. I was going through that, a lot of the debates and things like that. The question is, you are objects, you are a medium that connects the objects, right? That's the rope. But where does that object come from? Where does this originate from? That's the question.
That's a very good question. And the answer is the universe has always been there, meaning matter has always been there. Why? Because matter, an atom, three-dimensional atom, cannot convert to empty space, which is that which doesn't have shape. And that which doesn't have shape cannot spontaneously acquire length, width, and height and become an atom. So all matter has always been there, but we always think of birth. We always think that even God had some kind of birth. It's the universe has always been there. Matter has always been there in the universe. It cannot convert into space, and space cannot convert into matter. Period.
Okay.
We're done.
Very good.
So you are saying these are two different things. One is the object there, one is a space, which is one is the object always there, and the space always there. Somehow they are.
Space is not there because space doesn't exist. Space is that which doesn't have shape, and exist is an object that has location with respect to other objects in the universe. If God wants to exist, it's very simple. God needs to be made out of atoms, and then it has to have each atom has to have location. I should be able to point to God. There should be a line of direction from my nose to God's nose. No matter where he hides, he can hide in the 10th dimension for all I care. There's got to be a straight line of direction from my nose to his. Otherwise, he doesn't exist.
Well, I've got that, but I'm Rajan. Keep going.
Okay. So the the objects are has some space which is not object between them, right? That which is not object, you are saying is space.
Right.
Okay. So you have two objects, and there is something that which is not object between them.
Correct.
Okay, and that is connected according to you. A lot of things is a rope. There is a medium. That's
Physical
rope.
medium. It's another
Okay.
thing. Yes.
Okay, but the rope itself is not an object.
The rope is an object because it has shape.
But what is the difference between the object and the rope?
Well, that needs clarification because of the following. We always use
Okay.
the word energy to refer to this because no one knew what energy is. You know, how is it that one atom interacts with another and they say, well, it sends energy? They don't understand what energy is. We're saying that this famous energy was a rope. In other words, many ropes, really. But the point is that here you have two atoms, which we consider objects, and then we have this energy between them, which we never considered an object. We thought it was a concept. It turns out it's an object also. It's an object that we cannot see or touch. And so now we have two atoms bound by a mediator, a medium, a physical agent that's between them. Okay, so all of this is physical. All of these are objects.
So then your definition, then it's a very cloudy definition of rope, because the rope is an object. So then you have to come up with size of the object. So rope is extremely small object, and
Very
the
thin.
object itself is. So you have to. How do you define like you have a big one, like a small one? How do you define that? Like Earth
How,
is big compared to Moon. How do
how
you
do I define?
define?
How do I
How do
define
you
what?
define a big object versus a small object? How do you
It's
define
the
that?
same. Object is that which has shape. So both the
Huh.
rope in my hands, the atoms have shape. Both of them have shape. So anything that has shape, object. Anything that doesn't have shape, space.
Okay. Yeah. So then, how does the gravity change with the size of the object? How do you define that?
I
Do
got
you
a picture
quantify that?
there. Let's see if I can send you the.
Oh yeah,
Here.
let's try that. That's
Can
funny.
I show you this? You have time to see this?
Yeah, we've got another. Well, we've got
Okay,
all
so
night, but I don't know. Yeah.
Let's see if we can show you this. Where is it? Oh, where is it? Give me a second here.
No problem.
Sure.
Give me a
Take your
second.
time.
Let's see if we can get this in there. Where did I put it? Oh, because this illustrates perfectly well how this works, but I can't find it now.
Okay.
Here, but I don't know where I did. Anyways, let's see if I can explain it to you. A picture is worth a billion words, you know, but this is the way it works, okay? You have many ropes. You have many ropes connecting one atom to say the Earth. Okay. Oh, in fact, I do have. Hold it here. Let me, because this illustrates it perfectly. Hold it. Give me one more second, please.
No problem.
Because once you see this, I'll save myself 2 hours of explaining. Where is it? Principle. Here it is.
Video link.
Yeah, it's a video, but it'll give you an idea of how this works. So let me send it to your email. Can I do that?
Yeah.
Okay, so here.
As long as I can connect. Yeah.
Then Christopher will send to me from me. That's fine.
I can send it to you later, Rajan.
Sure, no problem. Thanks.
You'll be able to see it anyway, because we're going to show it right now. As soon as.
Okay, yeah, that's yeah.
But I will send you the link as well.
Okay. Yeah, if it is there, yeah, let's look.
Oh my God! Why am I having so much trouble trying to send something to? How can I put a link in YouTube link to you? Is there
You
a
could
way I
just
can do that?
you can just post it in the as a comment,
Okay, let's see if I can put that in there.
and I'll
Because
get
for
it from
some
there.
reason my thing doesn't allow me to do that. Paste. How do you paste this thing
If it
in?
doesn't work, you can send email to Christopher. He will upload it
Oh my
right
God!
now.
Am I having problems to just to paste this? All I want to do is just paste it. I don't
Yeah,
know how to
you
paste
should be
this
able to
thing.
just paste it into the post a comment
But it
box.
won't allow me to do that. I
Huh,
put it in comments
yeah.
and it won't allow me to paste it.
Oh, is that because but it's a YouTube link, so they should. Why not just paste the end of it, like the watch part?
Yeah, but it doesn't allow me to. I'm copying and I want to paste it. It doesn't allow me to. It doesn't give me
Um,
the option to paste. I don't know why.
would you be
Why
able to share it on your computer, your screen? If you share your
How do I
screen,
do that? Jesus, unbelievable. I
oh,
can't
no
send it to your
problem.
email. I can't do anything with it.
Well, if you look at the bottom of the screen, you've got microphone, camera, and then
Yeah,
a box with a plus sign in it.
yeah.
If you click on that and click share screen,
Video
and then,
file. Okay, let's see if I can do it with this.
and then go
Yeah,
window.
give me a second here. Let me
Yeah,
get my bearings here because uh
once you're in there, you'll be fine.
why am I having so many problems? All I want to do is copy and paste, and then I don't know how to do that. It doesn't. This system doesn't allow me to do it. Private chat, maybe.
You should be like, it's not a problem with your computer then. It's
No,
like,
no, it's not. It's just that it doesn't allow me to paste it. Oh, there it is. Hold it. Let's see. There it goes. You see that in studio
yes,
chat?
yeah, that's actually the private chat, but that'll do just as well. Nice one. Thank
Okay.
you.
The only way I could do it, I don't know why the system will not allow me to do anything.
Okay. Yeah, actually, I mentioned the private first, but that's good. It worked anyway. So which one
And
is
Rajan, take a look at that. You'll see how one atom is connected to every atom on the Earth. It explains quite a bit with a rope model. There it is.
Oh,
And you
okay.
may have to
You
run
are
it
pulling.
a couple
Oh,
times.
now you pulled it. Yeah, good.
Okay, what you have
Oh,
is one atom, one hydrogen atom connected to every atom on Earth.
now I cannot see it. Let me see. Uh,
oh, can you not see it?
no,
Okay, let's try that
private
again. So
private chat. So this one, right? Okay.
can you see what I'm sharing, Rajan? Hello? Rajan? Hello?
We go back. Yeah.
Can,
Uh,
oh, maybe
I,
I'm not. Hang on a sec. I'm not sharing it, am I not?
I just saw it for a minute, for a
Yeah.
second.
can you put it? Can you put it on? Yeah, yeah. Now I can see it. Thank you.
Now we can see it.
Yeah.
Okay.
Okay. I see F equal to MA 9 point. Okay.
Okay,
8 meters. The principle of
it's about the
equivalence.
principle of equivalence, but if you stop it there for a second,
Okay.
just so that I can explain what we're staring at. We have one atom, a hydrogen atom. Every atom on Earth, obviously I didn't draw all the ropes, but every atom on Earth is connected to that atom. It's got a certain distance from the Earth. As it approaches the Earth, all the ropes fan out. They spread out. Okay, so you have more and more ropes, independent ropes acting on that atom, and that's why you have the acceleration of gravity, because that's only one atom. Okay, so that atom could belong to an elephant or to a feather. It doesn't matter what. But the point is that all atoms on Earth are connected to it. Now, if you run it, it'll give you an idea, that you can put an elephant. It doesn't matter what you put in there. But what it does explain is something Einstein could not explain, why the principle of equivalence, why Newton's force equation is equal to his second law, force equals mass times acceleration, is equal to his gravitational equation. And this is what this is about.
Okay. I'll keep playing.
Yeah.
So this is just kind of what you were explaining already.
Yeah, it doesn't matter if it belongs to a feather or what.
Yeah.
See, if you freeze it there,
yes, sir.
Or go back yeah, go a little further. There you go. See, force equals mass times acceleration is equal to force equals mass divided by distance squared. The second law is equal to Newton's gravitational law. One is going outwards, the other one's coming in. What we're doing, we're looking at weight. We're saying that that atom has a certain weight at a given location with respect to the Earth. Why? Because every atom on Earth is connected to that atom. Okay, at that location, there's a certain number of ropes, that effective ropes that are connected to that atom. If the atom is now closer to the Earth, what happens? All the ropes fan out. They get wider. You know, there's superimposed ropes that now spread out in between. You have more effective ropes acting on that atom. That's why you have the acceleration of gravity. That's why, you know, that atom has different weight for different locations.
Okay.
So my question is, does the rope connect and disconnect?
No, because it's part of the atom. In fact, I have another one. If I can show you that one, I hope I don't go crazy trying to show you, but I can show you this, the construction. Give me a second here. Let's see if I can paste it on there. Let's see if I can paste it on there like I did with this one. I guess here. You receive that one?
Yep.
Okay, look at that one. It shows you the construction of the atom. It's made out of the same threads as the rope.
That's what I want
sand
to.
Or not? Sand, no sand. No sand.
So the rope ends at the edge of the atom, but one thread goes to the center, builds the proton dandelion or star, and the other one comes, the red one in this case, right, goes around and forms the electron shell that encapsulates the proton star. That's the atom. So the atom is made out of the same threads as the rope.
Okay, the atom in this case is a nucleus. Is it like a proton nucleus?
Yeah, that blue center that you see there, that's the proton, and it's made out of threads. See, those are threads. The rope stops at the edge. You see the rope stops at the red line, at the red circle. And what continues, one thread goes straight to the center of the atom, the other one goes around and builds the electron shell that encapsulates the proton star. So the atom is made out of the same threads as the rope.
Okay, but the rope, the nature of the rope is different inside and outside.
Correct.
The rope itself.
Correct. Inside you have thread, outside you have rope.
Okay, but what is the difference between the inside rope and outside rope? Are they electromagnetic or not electromagnetic? Electrical and magnetic. Your rope is made of electric, electric component, and you don't call it field, but electric disturbance and a magnetic disturbance, something like that, right?
No, we're not talking about electricity here. We're just talking about the construction of the atom and how they're connected to other atoms. They're connected by that rope. In other words, the two threads that make up the rope also build the atom.
Okay, so you have electric thread and magnetic thread in each in a rope.
Yeah, those are again. The issue there is that the words electric and magnetic are only for convention. Just want to make sure that's clear.
Okay, but inside also you have same. Let's use the electric thread and magnetic thread because so inside you have also rope, which is consisting of electric thread and magnetic thread, right?
Inside, there's only a thread, okay? Not a rope, but a thread.
Okay.
Inside
And
the
the
atom.
thread, but the thread, does it have electric and magnetic?
Yeah,
Are
those
they
are,
electric and magnetic?
again, just words. You know, it could be X and Y.
Okay. But is there a difference between that and the outside? Because the outside rope is like that, it's winding,
Correct.
and you have blue and the red things.
Right.
The inside thing, you are showing only a blue thing, right?
Well, the blue one goes inside, but the red one goes around.
Okay. Oh,
In
so
other words, remember, there are no colors here. I colored them only to distinguish the one that's going to build the electron shell from the one that builds the proton star.
okay, what I want to clarify, I'm not sure yet, is
Yeah.
what differentiates between the inside and outside? What differentiates the nature of the thread,
Well,
whatever?
again, what we're talking about is an assumption. We're saying this is the assumption with which we're going to explain gravity, light, etc. And so this is the model we came up with. I hope you're not asking who made this. Did God make this?
Uh-huh.
No. It was already there. The universe has already
Uh-huh.
been there. All matter has been there. So this is not made. It's just the assumption you have to make in order to explain gravity, light, magnetism, electricity, etc.
So it's an assumption. It means that it's much like the concept of space. You say the space is a concept, right?
Yes.
And then object, you are differentiating between a concept and an object which is you can actually see, or which is there, which exists.
Well,
So
no,
something.
let's make it sure we understand. It's not what you can see, it's not what you can touch. An object is that which has shape, a concept is that which doesn't.
Okay, so you can use the word exist, right? So object is that which exists is object. Can you say that?
I'm sorry?
Something exists. Something that exists is object.
An object that has location, we say that that's what existence is. Exist is an
Okay.
object that has location.
If it doesn't exist, that is space. Something that
Space,
doesn't exist.
if it's a concept, concepts cannot exist. Conscience does not exist. Love does not exist, not in physics. Intelligence doesn't exist for sure at Cambridge.
Okay. So concept is something that doesn't really, you cannot explain by exist. Concept is something that doesn't exist.
Concept, let's define the word concept so that we know what we're talking about. A concept
Okay.
requires two objects.
Okay.
A concept is a relation between two objects. So it's a concept is a word that invokes or involves two objects. It embodies two objects. That's why you need to define the word object before you define the word concept. And a concept is a relation. It's a contrast that you're making between two things. Humans invented all concepts. Father Universe, he invented all objects.
Then the rope comes to explain that concept. Is a rope not a concept? Rope is
No,
not a concept.
rope is an object. I mean, here it is. It's a physical object. It's got shape.
Okay.
Love is a concept. Time is a concept. Mass is a concept. But rope is an object. It's a thing.
Okay. So your rope is a medium that connects between two objects. Is that right?
Correct. Yes.
Okay. So you have at least three things I can think about. You have a concept, you have a medium, and you have object. Object you define first.
No,
And
medium is also an object. There's only two things, objects and concepts. Every word in the dictionary is either a concept or an object.
Okay. So rope is a different. Okay. What is the difference between two objects and the rope?
Yeah, but the rope is an object too. It's a medium. It's an object.
Okay.
The atoms and the rope all are objects. All have shape.
Saying, okay, so you have object. some object which is, I don't want to say quantum or something, it doesn't make sense to you, but it is a separate entity. Let's say entity. Entity is a good word.
It's the same thing as
Entity.
object. The synonym of object, thing, entity,
Okay.
body, they're all the same word in physics.
Yeah, I'm used to entity because I
Okay.
think that's a good definition.
Okay.
So there is entity. Entity is something, yeah, something that exists or something, right?
No,
Yeah.
not no. If the entity wants to exist, it has to have location. I can have
Ah,
a table that I'm thinking of. It doesn't exist. It's a thing, but it doesn't
uh,
exist because it doesn't have location. Neither
okay,
does a cube. An ideal cube of geometry does not have location. It's in our minds. It's not out there. An ideal
okay,
cube. So a
okay.
cube is an object because it has an entity because it has shape, but
Yeah,
it's an
yeah,
object that does not exist.
okay. So then you talk about location. How you say space is a concept. Then how do you define location?
Location, the set of distances. That's why we go in steps. We start with the word object. Okay. We
Okay,
say we have
okay.
two objects. The space between them we call distance.
Uh,
And now we have the set of distances from one object to all other objects in the universe. That's the location of this in the universe, among all matter. So this object exists if it has location. What is location? The set of distances to all other atoms or objects in the universe. That's
so
the
you have
location of
distance.
this in the universe.
So you have distance coming into the picture. Does that distance of exist in the concept, or is it an object? The distance itself.
Yeah, and existence can only involve object. Concepts do not exist. You cannot say that a
Okay,
concept exists because you cannot use the word exist rationally, consistently if you use it on concept. So you cannot say love exists in physics,
yeah,
in science.
okay. So very
In
interesting, and I
ordinary
like the logic
species,
aspect.
in ordinary speech, you can say that love exists or intelligence exists.
Okay,
Not
okay,
in physics. In science, you cannot say that because you got to use the word consistently. And the only way you can
okay,
use it consistently, the word exists, if you use it with
yeah,
objects, only with things. Things can exist. A table can exist. Love cannot exist.
okay. I agree with your logical thing. Logical you know, has to make sense over and over again,
Yeah,
whichever
it's a
way
new
you
language that I
apply.
invented, by the way. So it's
Okay,
hard.
okay. So you have only object, or I call it entity. So let's say stick with your definition, object and concept. These are the only two things.
Yes.
Okay. So in that sense, how do you describe or explain the distance? Is it an object or concept? Distance.
Distance is separation. It's a concept. It's space, just the space between them.
Okay, the space, which is
It
a
turns out
concept.
that just to clarify something, it turns out that under the rope model,
Uh-huh.
distance is the length of a rope. Because if you take two atoms and
Uh-huh.
you look at the space between them, those two atoms have a rope between them. So the length of the rope is the distance between two atoms.
Okay. But the
Under the
problem
rope
here
model.
is you don't believe in math, right? But the length
Well,
is a
it's
math
not that I don't
concept.
believe in math. I say that math, I studied a lot of math, and I'm telling you, math is useful for descriptions. I can describe with math. I can describe things with math, especially motion. Something moves, I can describe it mathematically. But I cannot, with math, I cannot tell you what a ball is or what light is.
Ah,
I cannot
true,
tell you
true.
what
That's
they
true.
are, what the mediators are just with math.
Yeah, that's why you have physics separate, math separate, and you are trying to combine. You're saying that creates confusion.
Yeah,
When
because
you
not only, when you talk about words such as field, which is a dangerous word, and you talk about words such as energy, what are we talking about? What physical object are we talking about? And they never were able to put their finger on that because it's a mathematical concept. Field is defined as a value at each point in space. That's not a physical object. That's a concept. What is energy? Again, capacity to do work or whatever. That's a concept. None of those are physical, but they say, oh, we transferred energy. No, I can transfer a ball. I cannot transfer a concept. I can transfer, love I cannot transfer. I have to transfer a table, a dog, a rock, but you cannot transfer concept. They say transfer information. Information is what the guy on the receiving end receives or interprets. That's what information is. You can't say you transfer information, not in science, but they use all this language that they created over the years, transfer energy, move a mass, vibrate a field, the flow of time, carry a force. It's a total irrational language that they've invented because they're moving concepts around. That's what they're doing.
Yeah, okay. I have two more questions. Then I'll give it to Christopher because he's the main. So I just I want to spend too much time, but couple of more questions. You are saying that the two objects communicate, whatever you call it, by signal, by torsion. So if it is a torsion here, immediately you have the other one with the speed of light. That signal is the disruption, whatever the disturbance is traveling as a signal, right? When
and
you do that,
the other atom.
At the speed of light, you are saying, at the speed of light, it's
300,000
communicating.
kilometers per second. Yeah.
Yeah. So that explains the entanglement type of thing, right? If you have clockwise and anti-clock, you showed that clockwise and anti-clockwise.
Mhm.
I mean, that's all, I think self-consistent. Yeah, exactly. Yeah. So I'll see it because I am looking from here. What you see as clockwise, I see anti-clockwise, something like that, right?
Right.
Yeah, because so the object here is actually anti-clockwise. The object there is seeing as clockwise.
Right. If just take any rope, 2-strand rope, and if you twirl it, from your end, it should be clockwise.
Okay.
And from my end, it's counterclockwise. And if I turn it around now, from your end, it's counterclockwise. From my end, it's clockwise. We're done. That's
Okay.
EPR. Einstein, Podolsky, Rosen, 1935.
All right, but wait a second.
Oh, yeah.
Wait a second. Sorry, maybe this is the point
Sorry.
you're getting. The point you're getting to is that entanglement is instantaneous, and the point I was making was that torsion would be instantaneous. So
let's clarify that. When we say there's no such thing as instantaneous in science or in physics, again, these people talk about instantaneous. Let's understand that word because it's very critical. Here's one atom on one side of the universe. And here you have another atom on the other side of the universe. They're on opposite sides of the universe, right?
Yeah.
And we're saying, okay, but hold it. This atom is turning this way, right? Let's say clockwise. And this one's turning counterclockwise, right? And now people say, well, hold it. EPR is instantaneous. That means if I turn this one counterclockwise, this one should be clockwise instantaneously.
Yeah.
That's what they're saying. And what I'm saying is the rope is already twirling, right? So you grab one rope and this one's going clockwise there and counterclockwise over there, okay? But what happens? This rope, anywhere I measure, I'm going to get the same result, okay, along this rope. Nothing changed on this rope. This one keeps rolling in the same direction, but you need to know which rope you're measuring. When they're looking at light, they can't pinpoint one photon at a time. And so they look at the whole beam and they say, oh, we have counterclockwise or clockwise. We measure here and that's what we see. Yeah, because those ropes are coming from the other side of the universe. They're already torquing in a given direction. It's not that they changed direction. It's that they were already torquing like that.
No, but that's what you're showing with the rope. You show it turning one direction and then turning the other direction.
Because I'm turning it the opposite direction. But what I'm saying is when you have two atoms on opposite sides of the universe connected by a rope, that rope's already turning clockwise or counterclockwise.
Yeah.
You cannot unturn it.
But the whole point is with the entanglement thing is this particle is spin up. So this one is automatically spin down. And if this one alters to become spin up, this one or the other way, spin down, then this one automatically becomes spin up or whatever,
Yeah. Okay. first of all, they never define spin. They don't know what they're talking about. Okay, that's the first issue. Spin is not spin. They say spin is, they illustrate it like spinning top, but that's not true. But that's one issue. The other issue, to answer your question here, is what they do is they look at a cross section at the endpoints, right? Yeah. There's a device called an ellipsometer, which I use quite a bit when I worked at AMD. And what it does is it measures the refractive index of a film, how light changes through that film, okay? So you have the polarizer and the analyzer. Those are parts of this ellipsometer. What happens? You do look at a cross section of light, a cross section of whatever you're measuring there. It's a cross section because that's where light comes into the aperture. Okay, so you're essentially measuring a cross section, and so what you're saying is, okay, here I measure and it's going clockwise, and over here I measure it's going counterclockwise. Okay, so yeah, if you're measuring the same rope, the same photon, then yes, you can say, look, here it's going clockwise, here it's going counterclockwise. Are you measuring the same rope? Are you measuring the same photon? That's the question. They say we turn it around in the opposite direction. What did you turn around? I mean, these people don't know what a photon looks like. They cannot see at the atomic level, but they're claiming that they handle one electron at a time and one photon at a time. Well, if they did, they should be able to draw a photon for me. They should be able to illustrate an electron for me, and they can't.
Okay, but that's a confusing part, though, because you're attempting to explain it using the rope model, but then at the same time it sounds like you're saying that this thing isn't a real thing. So I'm wondering why you're trying to explain it in that case.
Well, what I'm saying is that what they're measuring is clockwise and counterclockwise. That's the famous negative and positive of mathematics. It's really clockwise, counterclockwise. Mother Nature doesn't understand positive and negative. That's math that we invented. Okay. Mother Nature understands clockwise and counterclockwise because that's physics. Okay, it's something moving this way, it's something moving that way. She understands that. Okay, so I just want to clarify that point that, when you're measuring something from one end, it's clockwise, the other one, it's counterclockwise, because a rope can explain that. Something elongated can explain that. It's either moving this way or it's moving the opposite direction. The question is whether when you do that cross-section measurement, which is what they do for the EPR experiment, right, for the entanglement, etc. Okay. When they do that experiment, the question is, are we measuring the same rope? Are we measuring the same photon, the same light? Because they cannot get it to the point where they have a pencil sharp, a one-dimensional line with a bunch of photons lined up along that line. They can't do that. They never saw a photon in their life.
You agree that there is a rope and there are two entangled particles. Yeah. So you agree with that, and you agree with the concept or the description that they're trying to get across, which is that once if we're measuring one as clockwise and the other one is anti-clockwise, then if this one changes to the other, to its opposite, polar opposite, the other one will also change. And
if you can change it, yes. The question is whether they're measuring the same light at that point in time, because these atoms are going around. I mean, I don't know if they're measuring the same atom. I don't know if they can. Just conceptually,
doesn't matter what they measured, but we're saying that it's if the two things are connected and they're polar opposite, then if hypothetically, if one were to change its direction,
right, then completely, because you can only explain it with an elongated object, and I don't need this. I can do it with my magic wand. Here's my magic wand, right? And from your end, again, I can do it this way. Okay.
Yes.
And then when it goes the other way, it's got to be an elongated object. It can't be anything else.
Right, but in that case,
it can't be little particles that flow back and forth between your eye and mine. It's got to be this or that. It goes one direction or the other.
Fine, Bill, but in the case there with the magic wand, because that is like a properly rigid object and it's not too long or anything, it's
right.
When you rotate it, that's instantaneous. The change is instantaneous.
Yeah, of course, that's instantaneous. But what I'm saying, instantaneous means, see, we need to understand that the word time does not belong in physics. We should get rid of the word time because it confuses everybody. And instantaneous is a word that belongs within the realm of time. Okay. Father Universe does not recognize time. Father Universe is every atom in the universe at a given location. In the next frame of the film, Every atom in the universe is at a different location, but every atom is still there, right? Then in the next frame, they all change locations again. From frame to frame, all we have is the motion, the new locations of every atom in the universe. That's why time doesn't exist. You cannot travel back in time, for example, because the atom is no longer there. Because if the atom is still there, we're all crazy. It means that every atom is making a copy of itself in every frame of the film. That's why I can land on another atom. But if the atom's not there because it's now in the present, then there is no past and there is no future. Father Universe only exists in a cross section of time. She doesn't recognize time or motion. We recognize motion. The moon doesn't move for Father Universe. He looks at himself, he wakes up, he says, every atom in the universe is where it's supposed to be. And then he goes to sleep for 1,000,000 years, wakes up again in the nest, billions of a second, says every atom is there.
Yeah. But why use the analogy of a film then? Because films are copies, and they do.
I use the film because that's what humans, the observer, sees. The observer sees motion and time, measures time, right? But Father Universe is just every atom in the universe. The Father Universe doesn't recognize time. He cannot go to the past and say, all my atoms yesterday were over there. If they were, they're not there anymore. He doesn't have a file cabinet for every atom in the universe because every atom is now here. If not, what we're saying is that every atom is making a copy of itself in every single frame. Then yes, I can go past and talk to Napoleon because he's still there. But hopefully every atom of Napoleon is now somewhere else here in the present.
Right. Okay.
So the question is, your thing is based on objects and concepts, right?
Yeah.
So which means that the atom, you are saying that it depends on the location. So it moves, it is at one location one time, another location another time. But will they bump into each other, the atoms?
Why would they? No, they can bump into each other. They would push away. My point is that every atom in the universe, in a single frame of the universal movie, cross section of time, cross section of motion, only has location, static concept.
Okay.
If I get a cross section of the universe, right, of the movie of the universe, I should have location only, distance between objects, between every atom.
So your object is here at one location that moves. So that what it moves is the disturbance or the signal, disturbance signal.
Well, it moves to a new location. Everything moves in the universe according to us, but Father Universe is only every atom in the universe. He doesn't recognize motion. He only has every atom at a given location. It's like you. It's like you if you die tomorrow, right? All your atoms are there, right? Let's assume you're the only thing in the universe. You don't move anymore, right? You don't move. So you're frozen in time. Well, all you have is atoms. You know, every atom in your body builds you. That's you. That's your Father Universe at that moment in time. That's all there is, right? And what happens? If in the next moment you happen to move or something moves, every atom moves in your body. But it's not longer where it was before when you were dead. Now you're over here. Every atom is over here. No longer it's over there. So time does not exist because time is in our minds because we have memory. So we remember things and we say, oh, yesterday I was there because we have it in our brain. Father Universe doesn't have a mind. He only has atoms.
So it is like the movement is like a snapshot.
Right. It's a cross section of time, cross section of motion. It's only location of every atom in the universe. That's a slice of time.
Okay. So right now there's a snapshot. Everything is there. Then at another. So how do you say that another moment you have a different snapshot?
Yeah, I don't talk about moment. I talk about locations. We have new locations for everything.
But how do you differentiate between the earlier location and the present location?
Well, again, that's when we talk about motion, and we talk because motion is two or more locations of an object. So now you have motion because you have two locations, but to have time, you need the comparison of two motions. You have to have two motions for time. You need to have memory, and you need to compare the motions of one object with respect to another. Let me give you, for instance, an example. You have a watch, and on your watch, you have the second hand, it's moving, right?
Yeah.
Every time your second moves one tick mark, the
Hmm.
Earth moved around the sun 30 kilometers. That's the speed at which the Earth moves around the sun. So what are you doing? You're
Okay.
comparing the motion of the second hand going from one tick mark to the other against the motion of the Earth. Those two comparisons of those two motions, what we call 1 second.
Oh. So the
And
motion
that's what they use
is
it now.
more.
They use the other. They use the wave, the cesium wave. But but what I'm saying is, originally that's what we compared. We compared essentially one movement against another movement. We said that's a second. We gave it a name.
Okay. Okay. So the motion is a concept, not an object. Motion
Right.
is a concept.
Right.
Okay.
That's why
So
Father
you can
Universe doesn't understand concepts. Father Universe is just every atom at a given
no, but
location.
you classify in terms of something is an object. You have classification, like you have a table, right? You can put a table and you can say object and concept. So you either put it in this column or the other column. Everything.
Exactly. Every word in the dictionary is either an object or a concept. Even the table I have in my mind, which does not exist, doesn't have location, that table has shape. It's a thing
Uh,
because it has shape. The word table represents or designates that which has shape, whereas the word love is a process. It's a concept. It's not a thing. I can't point to love. What am I going to point to? A heart? I mean,
So it's like a category theory or a classification where you have only two things, object and concept. That's it.
exactly. That's all there
Okay.
is. So objects
Okay.
are what physics works with. I mean, if you're going to talk about the physics, you had better have an object because otherwise you're doing black magic. You're saying, the spoon falls because of what? Nothing came in contact with the spoon, with the skin of the spoon. It's just black magic.
So you have
Action.
always a rope. You are a rope connecting every atom every atom in one far away. You don't want to use universe things like that, but far away with another atom, another place. So always there is a rope connecting, like
Yeah,
a
with
rope
the rope,
connect.
at least you can visualize, you can imagine how Mother Nature is doing this magic trick. At least you don't have to believe in it, but at least you can conceptualize. You can say, okay, I can visualize what you're saying. With what we have in mathematics today, you can't do that. They talk about fields, energy, mass, all these mathematical concepts. And you say, well, I didn't understand squat. No kidding, they don't either.
Yeah. So I know that's interesting because originally what Christopher described about gravity. Then what my discussion of gravity when I started understanding of gravity is like a tension. There's a
Yeah,
tension between an object and the and this tension is what you call transmitted like a disturbance signal. Okay, that's my original. I mean, many probably decades ago, I was thinking about gravity. When I started thinking about gravity, I said
yeah,
there has to be like we use simple pendulum, and in that when you hang a thread and you have a small object there, and that is moving around, right? The simple pendulum, right?
yeah, yeah,
So
yeah.
in that way, yeah, in that way, there's a thread that connects with that whatever the pivot is with that one, and that's how it transmits the gravity. And it's very
Yeah.
similar to yours in the sense that any object will have a tension that connects between that and the earth, and this tension is the one that is pulling it or whatever, attracting it, and the tension is the one that makes it gravity. If you loosen that, for example, if you loosen that, it will not fall. It will not fall. So because of the tension, it falls. So it creates a tension. The atom in the spoon or whatever, and the earth, it creates a tension, and this tension is what is pulling that thing.
Well, here, right,
It's a
let me show
disturbance
you. Let
signal.
me let me give you a little example. Okay, here's the moon
Okay.
and the Earth.
Okay.
The moon goes around the Earth. Why? Because it's tied. Because there's something there.
Uh-huh. Uh-huh.
If there were nothing there, how can I do this?
Uh-huh.
Very simple. I mean, the sun moves the Earth around the sun. And you say, well, how does it do it? Well, hopefully there's a connection between our atoms and the atoms in the moon, because Newton's equation tells us that. But nobody ever put an object there because they say, well, I can't see anything, I can't touch anything, so there's nothing there. Well, the definition of an object is not that which you can see or touch. Definition of an object is that which has shape. There are objects we cannot see. There's objects we cannot touch. The air is one of them. I cannot see the air. I can touch it, but I can't see it. So, you don't see every object out there.
Yeah,
Anything made out of atoms better be an object.
Yeah, I see some similarity between string theory and yours, except that string theory is more mathematical, yours is more physics, where you have objects.
Hopefully physics is not the same thing as math. They put them together when they created geometry. They call this mathematical physics. Why? Because they started looking at geometric figures, and they started mathematizing them. But if you look at the geometric figures we have, the ones that we inherited from the Greeks, from Euclid and so on, they're all irrational. They're all irrational because you have the point, which is zero-dimensional. They tell you that, and you say, what do you mean, a zero-dimensional geometric figure?
Yeah.
What is that? I've never seen one. And a geometric figure such as a line, a one-dimensional line. What is that? I can't even see a one-dimensional anything. There's no object that is one-dimensional, much less a figure. And so they're talking about figures, and here's the building block of everything else, of the planes, of the solids, and they build them with zero-dimensional. Why? Because they're talking about locations. They're not talking about geometric figures. So they're saying, look, I can build a cube, and this is how you build a cube, and they can measure all that, and etc. But what are they doing? They're unrolling the measuring tape along the sides or the lines of the solids. So they're unrolling a measuring tape. They're saying this is 1 meter long. What is that? Well, what they're doing, they created a standard called the centimeter, the meter, whatever it's called, and they're unrolling a measuring tape. In other words, all geometric figures are made dynamically. Not one of them is something you can point to. They're never finished. They're still building the circle. The circle is what? Every point at a given distance from the center. But between any 2 points, there's always another point, and between any 2 points, there's more points. So they're still building to this day all the points between a circle, because they never finished constructing it. They're telling you how to construct the circle. They're not pointing and saying that's a circle. They're constructing it. The definitions are all constructive. They're building them little by little. So yeah, that's a problem. They built mathematical physics in the same way. Everything in mathematics, an equation, you look at an equation, any equation, it's motion. They're describing motion. They're saying, look, if you replace numbers in this variable, this is what you get. You get different points. And those points, what they're talking about is motion. That's motion.
Different location.
So mathematics is an adverbial language. It's a language only of adverbs. Adverbs describe motion. That's what mathematics is, and nothing but. So mathematics cannot tell you what invisible entity is between two atoms, because first it's invisible and intangible, and second, an equation cannot tell you that.
It could be locations or motion, depending on how you want to look at it. Okay, so
interesting.
Bill, I think we should wrap up there because it's getting nearly 2 hours. So I was only meant to go for an hour, but Rajan,
Chris, I think you're going to have more questions next time.
Absolutely, that's what I was going to say. Hopefully you'll come back on. We can continue this, or either way. So fascinating, Bill. And like I said, that was the first time that I really understood your idea, and it was kind of like a bit of an epiphany. It's like thinking about some massive geometric object that's like a almost like light pulsating through a circuit board or something is sort of the concept.
So one comment I want to make.
Yes, go ahead.
I'm working with Emery Taylor. I don't know whether it's about discontinuum physics, which means there is no 0 point. There are things individual, like your object. It's very similar, like objects, and then he talks about reality, things like that, which is very similar, like what we see the conscious mind, things like that, which is which is a concept versus very similar. It's a very similar thing. It's not exactly the same, but discontinuum physics says that they are objects, separate objects, and they're separated by something. Like you mentioned in this case is concept and the location. In your case, is you're defining by each location that
The
the location
definitions are
changes.
important. No doubt
The
about it.
pattern.
Definitions are
Yeah.
extremely important to be able to talk rationally.
Yeah. So what I'm saying is that individually there are things, right? Like objects. I call it entity. You say it's the same as object.
Same thing.
Your entity.
It's a
Your
synonym.
entity. Yeah. So
I call
entities
them entities
occur.
too.
Yeah. Occur in different places, right? And these entities, ex, you know, that we perceive is in our mind, but but the entities you are exist all the time, only their location change.
Separate from your mind.
Yeah.
I mean,
Okay.
what you have in your mind is one thing. What's out there is another. So what's
Okay.
out there is
That's-
objective. What's in here is subjective. You like I said, if you're drunk, you might see pink elephants. So for all I
Yeah.
I
I
do
call
some-
it domain. Yeah, domain of realities. Domain of realities. The different domain of reality. I think
Yeah.
we'll talk about later, but I have to think about a little more. I think
Yeah. There's a lot to think
yeah.
about.
Yeah. Okay.
Okay, great.
Thanks a lot. Exciting, interesting. Thank you.
We'll
Thanks
see
very
you.
much.
Bye, guys.